Okay, so today we're going to discuss the first topic about the immunohematology. Your immunohematology, or simply the blood banking, okay, this is a subject in medical technology wherein we will be dealing here about the blood preservation, the blood collection preservation, and a different technique to ensure that the unit of the blood given to our recipient during the blood transfusion is safe. Okay, so for this subject, we'll be using here the book Harmening 6 Ed. I think there's a recent edition for that, but good pa din naman ang 6th edition of this book. Okay, so we start our discussion here with the historical milestone that's happened here with the blood transfusion practices throughout here, the different year. Okay, so we start here with 1492 with Pope Innocent VII, wherein it tried to require, kita ba? Wherein Pope Innocent VII require a unit of the blood for transfusion. Okay, and there are actually 3 donors given to try to donate the blood here for Pope Innocent VII. But during that time, there's no regulation or standard procedure as with the collection, preservation of the blood. And eventually, all of them died with the blood transfusion procedure, including Pope Innocent VII. Then we have also here in 1628, William Harvey tried to describe the blood circulation pertains to your heart, how it tried to flow the blood within that one. And we have also here in 1667, the first blood transfusion from animal to human was done. And eventually, it was not also successful because, of course, the compatibility between the donor recipient is very different. And therefore, they are incompatible. So what are you expecting since you are donating the blood, transfusing the blood from the animal to human? Okay, then we have here in 1818, so the first successful blood transfusion, human to human, was done here, initiated by James Blundell. And we have here in 1840, Samuel Armstrong Lane, okay, tried to utilize here the blood transfusion as a way for the treatment of blood coagulation factor, clotting factor deficiency, hemophilia. And until now, we are also still utilizing the blood transfusion as a way of treatment or management of your bleeding disorder related to your hemophilia. Okay, then we have also here in 1867, so Joseph Lister tried to introduce here the use of antiseptic, specifically tried to use here phenol, making him as the father of the antiseptic surgery. Okay, so that's being used, antiseptic here, to prevent the infection, especially when you are collecting the blood sample here from the recipient or from the donor, I mean. In 1869, the problem with the blood preservation as to the allowing the blood here to remain unclotted for a longer period of time has been addressed by Braxton Hicks with the introduction of the first anticoagulant for the blood preservation in the form of your sodium phosphate. In 1901, Karl Landsteiner, known here for the ABO blood group system. And we have here 1902, De Castillo and Sturley try to introduce also or try to discover here an antibody related to your RH blood group system. Then 1914, Hostin also tried to introduce another type of the anticoagulant here for the preservation of the blood in the blood bank in the form of your sodium citrate. Then we have 1915, Lewison here tried to recommend the minimum amount of your sodium citrate needed to prevent the clotting process considering the ratio of your anticoagulant to your blood for the blood preservation. In 1916, we have here Rouse and Turner also tried to introduce here another anticoagulant in the form of the citrate dextrose. In 1943, Lutit and Mollison tried to introduce Okay, another anticoagulant in the form of your acid citrate dextrose. And later on, Gibson tried to introduce citrate phosphate dextrose as another modification in your anticoagulant for blood preservation. Okay, so we have here the blood banking practices in our country is under the regulation of the Department of Health. And we have here the law which try to regulate the blood transfusion practices in our country, including here the operation of all the blood banking services and facilities. So that's under here the RA 7719, other name for that, the Blood Banking Law or the National Blood Services Act of 1994. So we have here three main provisions with the National Blood Services Act of 1994. The first one, this law here tried to phase out all commercial blood bank in our country. The second one, it tried to have here the duty-free importation of the blood bank materials, equipments which are needed in the blood bank. So pag duty-free importation would try to reduce the cost here of the blood that's being eventually given or being sold here by or that is being given by the blood bank in our country. Okay, so ang binabayaran lang natin when kumukuha tayo ng dugo is most likely the processing fee. So because of that, so medyo less than naging costing here because again of the duty-free importation because of this National Blood Services Act of 1994. Okay, and then another one, so of course, this law also try to regulate the blood banking services and practices in the different blood services facilities in our country. Okay, then we have here the RBC biology and preservation. So we have here the three main important factors that should be maintained in order for the vessel here to reach the 120 days lifespan, especially when the blood or the red blood cell here has been stored or collected in the blood bag after the donor tried to donate the blood. So most likely dapat as much as possible we keep the RBC here viable in order for that not to rupture para magiging pores here it become functional when you try to transfuse that unit the blood to the recipient. The first one, you should have the normal RBC structure and of course here the chemical composition of the red cells should be normal as well. Another one factor we have here the hemoglobin. For the hemoglobin, it should have here the normal structure also and function as well. And lastly, we have also here the different RBC metabolic pathway that would be needed here by the red cells in order for that then to survive as well. Okay, we have here the RBC membrane. So we have discussed in the Hemo 1 that the RBC membrane is made up primarily of the proteins. Okay, so again, that's 50%, 52% of that is made up of the protein. 40% of that is made up of your lipids, and the remaining 8% is made up of the carbohydrates. So we classify also here the proteins as peripheral and integral protein. Okay, so your peripheral protein primarily made up the spectrin and actin. And we have also your integral protein. We have the glycophorin A and B, which maintains or provides the negatively charged particles here for the RBC membrane. Okay, for the red cell membrane to survive up to 120 days, so number one, it should have the property of deformability, or simply we call it one as the flexibility. Kasi having deformability, so the red blood cell here would able to change the shape or the morphology depending on the external environment. So dapat the RBC are able to adjust with the changes or the external factors. So in case here where the red blood cells would have here decreased ATP production that leads here to decreased phosphorylation, nagiging spherocyte ang ating RBC. So remember that the RBC normal shape is biconcave. However, when it tries to lose here the spectrin, or the would have here defects in spectrin, magiging spherocyte. Remember the spherocyte sphering, converting your RBC from your biconcave to become here the sphere is irreversible. So pag nabing irreversible, once it will be converted to the spherocyte, it can no longer be or return it back to the normal shape. The problem with the spherocyte, once the blood carrying the RBC having the shape of spherocyte is being taken up or carried in your spleen, the spleen would see your spherocyte na RBC here as abnormal na RBC. So once the spleen were able to identify that one, that's your spherocyte or RBC having an abnormal morphology, so ang gagawin ng spleen ay papatayin niya si red cell natin. So once the spleens try to sequester that one, that would result here to the red cell destruction and therefore decreasing the lifespan and the number population of your functional or viable na red blood cells, and we don't want it. That's why the red cells here should able to maintain its deformability, flexibility with that. The second function of the RBC, we have here the permeability. So pag sinabing permeability, it's just the ability of the RBC membranes to selectively allow some substance to go in and out of the RBC membrane while restricting other substances. So we have here the following: chloride and bicarbonate is highly permeable. What do I mean by permeable here? So your RBC membrane will just let your chloride bicarbonate to go in and out without restriction. But for some ions, for example, we have the sodium and potassium. So very strict ang ating RBC membrane with the regulation of in and out of your sodium and potassium. So it should be maintained that you have your high concentration of the sodium dapat sa labas, because we consider the sodium as a major extracellular cation. So extracellular dapat sa labas siya. While you have your high concentration of potassium inside of the red blood cell membrane, because again, that one is your major intracellular cations. So we have here the relative ratio of the sodium and potassium in and out of the RBC membrane. So intracellular, your sodium is 1 compared with the 12. So given naman yan kasi 'di ba, intracellular mas mataas talaga ang potassium. So in extracellular, so you have your 25:1. So 25 equivalent to the sodium and 1 for the potassium. What then regulate here the passage or the transport of your sodium and potassium in and out of the cells? Basically, that one is through your sodium-potassium ATPase pump. Okay, the sodium-potassium ATPase pump is actually the one which try to regulate here the transport of your sodium-potassium in and out of your RBC membrane. Another one that's being regulated here, we have your calcium level. So the calcium here is being regulated by another transport protein in the form of your calmodulin. So it's a calcium ATPase pump. So kailangan ng ATP for that to move your calcium. Okay, so when the red cell here try to lose ATP, ang nangyayari ay nabibuild up ang ating sodium and even your calcium inside the red cells. Once na build up ang sodium and even your calcium, that result here to the naging rigid ang ating RBC membrane and eventually dehydrated because try to lose their water because of that. Okay, so calmodulin help here then to regulate the transport of your calcium in and out of the RBC membrane. Okay, then as our review with your HEMA1, so we have also here the different metabolic pathways which are needed by the red blood cells here to survive, because remember that the mature red blood cell do not have the nucleus. So therefore, it relies on this different metabolic pathway in order for that then to have the different byproducts in order for that to maintain its viability up to 120 days. The first one, we have here the glycolysis. The glycolysis here is the major product of your glycolysis would be the ATP. ATP serve here as to the many significant function or contribution to the RBC. Most likely, the ATP try to maintain the biconcave this shape of the RBC. Another one we have here, the pentose phosphate pathway, also called here as your glutathione synthesis. Okay, basically that one is used here for the production of your NADPH, and that is needed for your glutathione synthesis. Methemoglobin reductase pathway would maintain here the iron in your hemoglobin in the ferrous state. And the ferrous state is the functional state of the iron in your hemoglobin. Pag ferric ito, hindi makapag-bind ang ating hemoglobin sa oxygen and therefore could not transport the oxygen. And pag hindi nakapag-transport ng oxygen, it will deprive your tissue with oxygen. And very important, we have here the Lubering-Rappaport pathway. Again, this one is a major product for that is your 2,3-DPG or this phosphoglycerate or biphosphoglycerate. Again, your 2,3-DPG is very important. We try to affect your oxygen dissociation curve or your ODC. Okay, now we have here your hemoglobin structure and functions. So remember that your hemoglobin should be in the functional state in order for that to carry oxygen from your lungs going to your different tissue or body and able to transport as well here your carbon dioxide from your tissues and try to transport it back to your lungs for excretion para may labas sa katawan natin. For the functional hemoglobin, you should have the following. So number one, you should have an adequate iron supply. Another one, you should have a functional and adequate na heme synthesis with the production of your protoporphyrin ring. And you have here also an adequate globin synthesis. Para meron ka ng heme plus your globin, we're going to combine to form here your normal hemoglobin structure. As a review ulit, we have also here your oxygen dissociation curve. So we have your shift to the left. Shift to the left here. So dito sa left, basically characterized here by an increase in the binding or affinity, and that one would have decrease na delivery of the oxygen. So it occur here if you have an increased pH or your alkalosis, decreased carbon dioxide, decreased temperature, and decreased 2,3-DPG. So usually your shift to your left is seen here if you have your high concentration of mga abnormal hemoglobin, your hemoglobin F, for example, and even transfusion of your 2,3-DPG depleted na blood, kaya nga mababa. Depleted blood, so mintas yung mababang 2,3-DPG here. So, ganun, correlate sila. Your shift to the right, on the other hand, is characterized here by an increase in the delivery of your oxygen. So, pag-deliver ka ng oxygen if your tissues are needing oxygen. So, your tissues are needing oxygen here because you have an anemia. Therefore, you shift to the left. We consider that one as our compensation for your anemia problem. So, shift to the right will be an increase in carbon dioxide, your temperature to 3 pg plus we have your decrease in pH acidosis. Okay, so we have here a healthy individual could donate here approximately 450 ml the blood. Okay, so you should weigh here approximately 50 kilograms or 110 pounds in order for you to donate approximately 450 ml of the blood plus or minus 10%. So, plus 10% ito is 45, tama ba? Minus 45, so that will be the maximum. So, 450 plus your 45. Okay, then 450 minus 45. This is the maximum volume of the blood wherein the patient can donate if you weigh here 50 kilograms. And this is the minimum blood wherein that one can donate the blood. So each of the blood bag here, 450 ml, contains approximately 63 ml of the anticoagulant. So this is the blood bag. Sometimes we're able to see here blood bag na may satellite bag. Ganon. Nakatouch siya dito. So may mga blood bag naman na mag-isa lang siya. However, here you could have here as pwede siyang 2 or 3 or pwede siyang 4. Okay, so pag ganito siya, pag we have your satellite bag, it would allow you to prepare your component blood here, component preparation through an closed system. Pag sinabing closed system, pwede mo siya ma-transfer blood component from one component here after centrifugation to the next without breaking here Okay, that become a closed system. Okay, so pag sinasabi nating component preparation, so component preparation here is a process whereby you try to prepare the different blood components from whole blood. So we have here the so-called light spin. So these are just pertaining to the centrifugation. So light spin would have here 3,200 RPM for 2 to 3 minutes. And the heavy spin is for 5,000 RPM for 5 minutes. So like for example here, again, so pwede yung ating blood bag dito, meron kang satellite bag, ganyan, naka-attach siya, or pwede din siya mag-isa. Again, pag may satellite bag, it would allow you then to prepare your component here in a closed system. Pag open system kasi, like pag mag-isa lang ang blood bag natin, okay, so that's become here an open system for you to prepare different other components. Okay, so whole blood, you try to centrifuge that one through your light spin using the centrifugation time and speed. After centrifugation, so what you have here, okay, magko-concentrate ang PRBC natin. Pag RBC, then we have here the plasma, the upper portion. The plasma approximately 250 ml and the PRBC consists here 200 ml. Again, kung this is may satellite bag ka, you could transfer the plasma. So may tinatawag tayong extractor. So usually pang ano mo lang ito, ipupush mo lang to para ang plasma mo ay okay, lilipat dito para lumipat siya sa satellite bag mo. Pag lumipat ang plasma mo dito, you could perform again here the heavy spin. Okay, so heavy spin is by centrifugation at 5,000 RPM for 5 minutes. So after centrifugation of your plasma, what you have here, magka-concentrate, magkakaroon ka dito ng mga puti-puti dito, that become your platelet-rich plasma. So mga platelets, makikita mo na dito. Or you call it once your platelet concentrate. That's approximately 50 ml. Then you could have your remaining plasma. Since platelet-rich ito, ang remaining wala ng platelet, you call that one as your platelet poor plasma. And that's constitute here approximately 200 ml. So, pwede mo ulit dito, pag may another satellite bag ka, pwede mo siyang ma-transport. Okay? Ano mangyayari? Like, for example, your mother bag here, wala siyang satellite bag. Kung may isa lang ito, you can perform here your light spin. But then again, after your light spin, what you have your PRBC, then you have your plasma. So, pag tinanggal mo ang plasma, wala ka nang masasalinan. Okay, and therefore, hanggang dito ka lang. Hindi ka makapag-proceed dito. And at the same time, para tanggalin mo itong plasma, ikakat mo ito. 'Di ba? Pag kinat mo ito, that become an open system na tinatawag. Pag open system, ang preparation mo, ang expiration nito ay magiging 24 hours na lang. Ganon siya kaigsi. Why? It's because here in the open system ka, most likely, there's a chance, possibility that your unit of the blood will be exposed already to bacterial contamination. And therefore, it would reduce the expiration to 24 hours if you're doing the open system preparation. And then again, you could have the open system preparation lang pag mag-isa lang ito, wala kang satellite bag or wala kang madami ditong satellite bag. So, isa lang siya. And at the same time, pag mag-isa lang ito hanggang PRBC preparation ka lang, you could not prepare your platelet concentrate with that.